Now the third factor, surface area. Of solid reactant. So as surface area increases, number of collisions between particles increases, so the rate of reaction increases. Example, if you have magnesium plus hydrochloric acid, so here you have two cases. The first one, magnesium, here the solution of hydrochloric acid, and here magnesium, and here as powder, magnesium as powder. Same amount, but here in powder case. So in case B, particles are surrounded with hydrochloric acid, so collisions between magnesium and hydrochloric acid occur faster than in case A, because here just the surface particles are in contact with hydrochloric acid, but here particles, almost all particles are in contact with hydrochloric acid. So here number of collisions between magnesium and hydrochloric acid increases. So as number of collision between particles increases, the rate of reactions increases. Now the fourth factor is concentration or pressure of reactant. So the rule is, as concentration of particles increases, distance between particles decreases. So when particles become closer to each other, so number of collisions between particles increases, so the rate of reactions increases. Again, as concentration increases, distance between particles decreases, so number of collisions between particles increases, so the rate of reactions increases. For example, if you have 1 molar of hydrochloric acid or 5 molar of hydrochloric acid. So here amount of hydrochloric acid in case A, which has the lower concentration, for example like this, but in 5 molar the amount of hydrochloric acid increases. So the distance between particles decreases, the collision between particles increases, so the rate of reactions increases. So again, according to concentration, as concentration of particles increases, they become closer to each other, so number of collisions between them increases, so the rate of reaction increases. Now, what about pressure? Pressure affects just the gas particles. So, what is the rule? As pressure increases, the same rule, distance between particles decreases, so collision between particles increases, so the rate of reaction increases. So an example, if you have here gas particles and here in case A and here B, here you compressed the container, so particles, in this case particles are closer to each other, so number of collisions between them increases, so the rate of reactions increases. So again, according to the fourth factor, it's concentration. As concentration increases, number of particles increases and the distance between them decreases, so number of collisions between them increases, so the rate of reactions increases. Now what about pressure? It just affects the gas particles. As the pressure increases by decreasing the volume. So when pressure increases, distance become closer to each other, so collisions between them increases, so as collisions increases, the rate of reactions increases. Now the last factor is presence of catalyst. So what about catalyst? Catalyst, substance that speed up the rate of reaction by providing an alternative pathway for the reaction with lower activation energy without itself being consumed during the chemical reaction. Again, so catalyst, substances that speed up the rate of reactions by lowering the activation energy. If you remember the energy diagram, so here for example the reactants, and here product. So if catalyst is used in the chemical reactions, the activation, here the activation energy, so catalyst, if catalyst is used in the chemical reactions, the activation energy lower. So here with using catalyst. So when we use catalyst in the chemical reaction, activation energy decreases, and as you know from section 1, reaction with lower activation energy, it has higher rate of reaction. So rate of reaction increases. So the last factor is the presence of catalyst. As catalyst is used in the chemical reaction, so the rate of reaction increases. Why? Because catalyst provide an alternative pathway for the reaction with lower the activation energy. So catalyst decrease the activation energy of reaction, and as here the activation energy when we use catalyst, so as activation energy of the reaction decreases, so the rate of reaction increases. Now you have to know that catalyst does not change the energy of reaction. It just increase the rate of reaction by lowering the activation energy, but the energy of reaction does not change. Energy of reaction delta E. As you remember from section 1, energy of reaction is the energy of a product minus energy of reactant. So here, for example, 2, 20, 40, 60, 80, 100, and so on. So the energy of reactant is 40, and the energy of product is 60. So the energy of reactant does not change, and the energy of a product does not change by using catalyst. So the difference is 20 kilojoule. Again, catalyst just lowering the activation energy, so the rate of reaction increases, but it does not change the energy of reaction. Energy of reaction, the difference energy between reactant and a product, they are fixed. Just the activation energy decreases. So, summary for this section. Reaction rate means speed of reaction. For a reaction to occur, there are two conditions. Particles must be collision with enough energy, and they must be in correct orientation. So any factors affect these conditions will affect the rate of reaction. And you have to know, as collisions of reaction increases, the rate increases. And as the energy of reactions increases, the rate increases. So any factors affect the number of collisions or the energy of collisions, it will affect the rate of reaction. So the first factor, nature of substance. So here, it depends on the state of matter, bond type, and bond strength. For state of matter, the rate of reaction for gas particles greater than liquid and greater than solid. Why? Because in gas particles, they are free to move, so number of collisions between particles increases, so the rate of reaction increases. But in solid particles, energy is used to break the bond, then the reaction occurs, so it has slower rate. And for the second one, bond type, rate of reaction of ionic compound greater than covalent. Why? Because ionic compound direct dissociate to ions when dissolved in water, and the reaction occur. But here ions direct dissociate to ions when the reaction occur. But in covalent compound, energy is used to break the bonds between reactants, then the reaction occurs, so it has a slower rate. Then we talk about here temperature. As temperature increases, kinetic energy between particles increases, so energy of collision increases, then the rate of reaction increases. Surface area, which affects solid reactants. As surface area increases, he has powder. So here, number of magnesium particles that in contact with hydrochloric acid increases. So number of collisions between magnesium and hydrochloric increases. So as number of collisions increases, rate of reactions increases. Then concentration or pressure for gas particles. So as concentration of substance increases, number of particles increases, so they become closer to each other. So the collision, number of collisions increases, so the rate increases. And for gas particles, as the pressure increases by decreasing the volume. So particles become closer to each other, so collision between them increases, so the rate of reaction increases. And the last one, presence of catalyst. Catalyst, substance that speed up the reaction by lowering the activation energy. Here, without itself being consumed. So mass of catalyst before reaction equal mass of catalyst after reaction. It's just lowering the activation energy without it being chemically changed or consumed. So when we used catalyst in the chemical reaction, it lowered the activation energy, so the rate of reaction increases. And you have to know that the difference in energy for a reaction, which is mean the difference between a product and reactant, does not change by using catalyst. Thank you.